In this video, I'm going to introduce you to the idea of limit. So, we are talking about limit. So, in order to talk about limit, what I'm going to do, I'm going to consider a function. So, let my function f(x) is x squared minus 1 over x minus 1. Now, here's the thing. If I ask you what are the values the function is defined, you will say, you know what? I can easily simplify this function and I can rewrite this function as x minus 1 times x plus 1 over x minus 1. Right? So this is the first step you will do, right? Now, if you simplify further, what will you do? You will cancel out one term from the numerator to the denominator, and the thing that you will get, the rest of the function, which is what? X plus 1. Right? So basically you will say, you know what? Yes, my function f(x) is basically x squared minus 1 over x minus 1. And I can reduce that function to x plus 1. Now, if I ask you, hey, you know what? Can you define this function at x equals to 1? Then, what will you do? The first thing you want to do, you want to check the value of function f(x) at point x equals to 1. So what will you do? You will write f of 1 is equal to, I'm going to substitute x as 1, so I will write 1 squared minus 1 over 1 minus 1. So 1 squared is basically what? 1 minus 1 over 1 minus 1. So 1 minus 1 is what? 0. And then 1 minus 1 is also 0. So I have my 0 over 0, right? Can we define this? Probably not. So what will I write? I will write undefined. I will write undefined. So what we saying? We are saying at x equals to 1, the function is 0 over 0, which is what? Undefined. Right? So as you can see, function is defined for all the values of x but 1, because at 1 the function is 0 over 0, which is undefined. Now what I'm going to do, I'm going to use a different approach. So I'm going to draw the graph of this function. So the graph of this function is like this. This is my x-axis and this is my y-axis, right? And then as you can see, my function is basically x squared minus 1 over x minus 1. And if we graph this function, I will get a graph of the function like this, right? Except the fact that at x equals to 1, which is right here, at x equals to 1, there is a small tiny gap that I'm going to use a circle, an open circle. So at that point x equals to 1, we don't know what is the value of the function, which is basically what? At x equals to 1, if I ask you what is the value of the function, you will say, you know what? I don't know. So that's what basically this open circle represents. So what we are trying to say? We are trying to say that the function is defined for all the values of x except when x is 1. Now, let's try to understand a different perspective. So, it's like this. This is a highway and one person is driving a vehicle from bottom to the top and another person is riding a vehicle from top to the bottom. What will happen if the person hits that spot? You know, there is a gap there, so both the people will fall at the x-axis, right? And we don't want that, right? So what we are trying to say? We are trying to say that if you approach at point A from left, or if you approach to the point, this point from right, what you can do, you can basically find the value that is close to x equals to 1 but not at 1. So if I have that condition, what will I do? That's when we introduce the idea of limit. So for limit, we use a symbol, we call it LIM. We don't write limit, we just use LIM for the limit. So what I'm going to say? I'm going to say when we are approaching to point 1, like x equals to 1, from left or right, we can write limit x tends to 1 of fx, right? That is equal to, I have x plus 1, so I will write 1 plus 1, that is equal to 2, right? But this point is when we are approaching from either left and right, but not at x equals to 1. So basically, at these conditions, we introduce the idea of limit when the function is defined. So what I'm going to do, I'm going to write limit x tends to 1 fx is basically what? 2, right? And this is basically the limit of the function, this given function at x equals to 1. But you need to understand that the function is not defined at 1, right? It's right here, not defined at 1. But if you approach the function at point x equals to 1 from left and right, then the value of the function is 2. Now, let's consider another example. So my example is my function fx is equal to 3 when x is less than equal to 0 and 7 when x is greater than 0. Now, in order to explain this function, what I'm going to do, I'm going to grab this function. So this is my x-axis and this is my y-axis, right? Now, what we need to do, we need to grab the function when x is less than or equal to 0. The value of the function is 3. So this is 1, 2, and this is 3. So which is basically what? Left of y-axis. And then this is 4, 5, 6, and 7. And x is greater than 0. The value of the function is 7. So I have an open circle right there for all the values greater than x equals to 0. So as we can see, the first part of the function is when x is less than or equal to 0, the value of the function is 3. So if I go left of y-axis, this will be my function. And the second part of the function is when x is greater than 0, the value of the function is 7, which is on the right side of y-axis, and this is my 7. So I'm going to write this one as 3 and this one is 7. Now, if I want to find the value of the limit, so the limit of the function at x equals to 0 for fx, what will be the value of the function? Now, look at this. When x is equal to 0, the value of the function is 3, which is right here. So, limit x tends to 0, fx is 3. And this is how we'll find the limit of the given function using this type of graph. Now, you need to understand that the idea of the limit is basically the starting point of calculus. And not necessarily every function is defined for all the values on the x-axis. Sometimes the functions are not defined for some particular value. And this is how we will define the limit mathematically and using the graphs.